Okay, here we go. We are on lesson 8 and 5, lesson 1. This is the first lesson of the fifth unit for 8th grade. Congratulations, we've finished 4 units and we got 2 to go. These are the 2 shortest units in the year. So we should be done with this in 26 more lessons. Give you 25 more lessons. We've done 74, 25 more. That makes 99 for the year, and you will have learned a full year of 8th grade math and a lot of good stuff. So let's talk about what 8 and 5. 8 and 5 builds a little bit on 8 and 4, just like everything that we do. Math is constantly building on what we've already learned. In today's lesson in particular, we are going to work on linear relationships. That's our big building block. And so we're going to focus today again on mostly on word problems, verbal models, and how they connect. So a lot of this should be familiar to you, and I'll try and connect that prior learning to what we're doing today. So let's move on over to our magic touchpad, draw pad, and let's talk about lesson 1. So the title is Modeling Linear Relationships. Linear relationships is just another word for things that are modeled by a straight line or a linear equation. So relationships between 2 things modeled by a straight line or a linear equation. Well, we know that straight lines, this is talking about the graphical version. The graphical version, and the linear equation is the algebraic version, right? So the linear equation is y equals mx plus b, like y equals 2x plus 4. And then the graphical version is just a straight line, something that looks like this. That's the graphical version. Okay, so let's erase that, and then let's talk about these. Just a few examples, just to bring it all back. We just did all this, but let's just continue to remind ourselves. Some examples are running at a constant 5 miles per hour. So I can graph that. It's a straight line. So I can graph or write the equation. Okay, I run at a constant 5 miles per hour. And remember, whenever we're talking about constant, the constant is the key, a constant rate. This is the key that tells us it's a line, and we have a linear equation. The rate, 5 miles per hour, often this keyword per will tell us that we're dealing with the rate. And so this is the rate or the rate of change, and that is our slope. So let's just don't forget any of this. That's going to be our slope. So in this example here, pizza costing $3 per slice, we have this is going to be our slope. $3.50, that's going to be our M. And then here, I eat 4 Skittles per minute, and I could here say at a constant rate. Every minute I'm going to eat 4 Skittles. And so our rate is 4 Skittles per minute. And we recall whenever we talk about a rate, we have the y is going to be our unit. This is our unit on top is always going to be our y, and our unit on the bottom is always going to be our x. So when we graph these 4 Skittles per minute, our minutes will be here and our Skittles will be here. And our M is equal to 4. And in all cases in these examples, we don't start with anything and we don't have an initial value. So in all 3 cases here, our y-intercept equals 0. So in this first case, our equation is going to be y equals 5x. Our slope is 5. In this second case, our equation is going to be y equals 3.5x. And in this third case, that's going to be y equals 4x, right? There's not going to be any y-intercepts on any of these examples, but don't think you're getting off the hook, because our examples coming up are all going to have y-intercepts that are not equal to 0. So again, in summary, as we talk about these word problems and we model our linear relationships, just keep in mind that the rate of change is our slope. This is what you learned all through lesson 4, and that our starting point and our initial values are our y-intercepts. One other tool that we're going to use just to cap this off is, we can have straight lines, linear equations, and we also can have tables, or also called T-charts, which are, I call them, these are the same thing. Sometimes I use the word T-chart, sometimes I use the word table. So let's go and let's look at 3 examples. And I don't think I labeled these homework help, but I'm just going to go ahead and write these as homework help, because the homework is going to be similar to all 3 of these problems. Okay, so what do we have here? We have a T-chart. This is our T-chart. Here we're going to have an equation that we're going to write. And here we have, obviously, a graph. All right. So we're going to talk about modeling linear relationships. And so we're going to start over here with a verbal model. Remember that word, verbal model? This is a word problem, or a verbal model. So this is a verbal model, this is a T-chart model, this is a graphing model, and this is an equation model, all the same thing. So Joe is saving for a pair of shoes that cost $120. He has $30 saved, and he earns $8 per hour babysitting. So let's model his savings, and then B, we're going to answer the question, how many hours will it take to earn $120? But let's forget about what he's trying to get to. Let's just think about modeling his savings. So we can do this in one of 3 ways. So let's start with each version, and we won't convert between the 3 of them. We're going to start here with the verbal model and show how you can take the verbal model directly to a T-chart, directly to an equation, and directly to a graph without having to have any intermediate steps. So let's start with this T-chart. And let's just take a look and let's figure out, if he works 0 hours, how much will he have saved? Because that's going to be our starting point. There's going to be no negative hours worked, which is why, again, on our graph, we're going to stick in quadrant 1. So if he has 0 hours worked, how much money does he have saved? Well, let's look at this equation. He starts with $30. So this is our $30 saved. Now let's say he works 1 hour. Well, he earns $8 for every hour, so now he has $38. 2, he adds another $8, 46. Let's say he works 5 hours. I'm just going to say, put 3 and 4. If he works 5 hours, he will have earned how much? He will have earned $40 from his babysitting plus $30 to start. So he will have had 70. And let's say he works 10 hours. 10 hours, he will have earned 80 plus 30, or 110. So this is our T-chart, and we can fill in as many data points here as we would like to. But it's kind of tedious, and it's kind of hard to look at this thing and really get a good idea of how much he's made in 15 or 3. With this model, you can see exactly how much money he would have at any point in time that you've calculated, but the other ones aren't really that easy to see, or at least not for me. So now let's talk about, let's do the equation version. So here in the equation version, we have learned now how to take verbal models and convert into equations. Now, to make an equation, you need to have y equals mx plus b. And so we're looking to fill in the m and the b. And so the m is our rate, and our b is our start. Right, so let's see, what is his starting value? Well, he starts with $30, and that's a positive 30. So we know that's our y-intercept, or our b. And what's his rate? $8 per hour. So here's our equation, y equals 8x plus 30. We can just write that given this information. And this is where y is equal to our dollars saved. To be completely accurate, you have to say what this y is and what this x is. And our x is equal to our hours worked. And to be totally precise, we have to say, well, x has to be bigger than 0, or bigger than or equal to 0. Right? Because you can't work negative, because you wouldn't say if he'd work -1 hours, he'd have $22, because you can't put a -1 in here. It's nonsensical for him to work negative hours. So sometimes you have to make sure that you specify your what they call constraints. The hours worked always has to be at least 0. All right, good. So now we're off in cooking with gas. We have our equation. We have our T-chart, and we're looking at our graphical model. Well, similar to our equation, we can kind of look over here and we can say, well, is that the right color? Yeah. Well, he starts with 30. We know it's 0 hours worked. He's got $30. And now we kind of got to do this the same way we did this T-chart. Well, let's say after 5 hours worked, how much did he have? Well, after 5 hours, he had 5 times 8 plus 30. 5 times 8. So he had, after 5 hours worked, he had $70. There's our 70. And now we can make our line because we have 2 points. Now, notice I didn't just come in here and say 1, and after 1 hour, he made $38, because it's sometimes hard, if you do that, to draw a really good line, because sometimes I'll come through here, whoops, and do that. Sometimes you'll come in here and you'll say, well, that's our line. Or sometimes you might start here and go like this. And both of these lines look like they kind of go through both points, but see how they're way off? So this is why I choose 2 points that are a little further apart, so we can get a really good line like this. So there we go. So now we have a good line here. Okay, so now we've modeled it. We've modeled his savings with a graph, an equation, and a T-chart. And we can start to answer some questions. So let's answer the question graphically and with an equation. Say, when does Joe have $120? Well, on the graph, it's really easy to see. We go up and we say, well, when does Joe have $120? Well, we go all the way up $100. He has it here. He'd have to have $120 here. So we go straight across. This is the 120 spot. We'll go straight across to here, and we'll go over to here. And then we'll come straight down to here. There we go. So at $120, let's make this in a slightly different color. So this point here is a little more than, it looks like it's a little bit more than 11. So, you know, like 11.2, comma 120. So it looks like our answer is a bit more than 11 hours. So our graph can give us a good estimate. So this is a good estimate. right? Graphs are often never exactly perfect. So if you wanted to know, but I'm good with that. So if I was Joe, I'd say, I got to save about 11, 12 hours, and that'll get me where I need to go. But if I wanted to know exactly how many hours, I'd come down here to my equation and I'd plug it in. I'd say, well, if I want to know when I have $120 saved, I'd say, well, this has got to be 120. My Y, my dollar saved has got to be 120. And so I have to figure out how many hours worked. And so we plug in our numbers. I need 120 for Y. So let's take this over here and say, well, 120 equals 8x plus 30. And then we'd solve for X, which is our hours worked. So let's do that for fun. Minus 30 minus 30. So 90 equals 8x. And we divide both sides by 8 to get our answer. And that will be x equals, and our answer is 90 over 8. So let's do that over here because it's the only spot we have left. And we'd say, well, that's 1, 8, 1, drop you down, you're 0, 1. 1 times 8 is 8. 20, 8 into 20 is 0.2. We had a good estimate, 11.2 looked pretty good. But then 2 times 8 is 16. 20 from 16 is 4. Drop down your 0, 5. There we go. So that's our exact answer. It would be 11.25 hours. And maybe he can't work a quarter of an hour. Maybe 0.25 hours, no one pays him. You have to work a full hour. So then his answer would be 12 hours worked. But you have to, in context of this question, the best answer that we can make is, well, it's 11.25 hours. And we'll put that down because there's nothing in this problem that says you can't work a partial bit of an hour. So we'll just, work our 11.25, take our money, run, go to the store and buy our shoes for $120. So hopefully this makes sense. Again, verbal models, T-charts, graphs, equations, all the same thing. All can answer questions about the problem. Some versions of the model, like algebra, can give you exact answers a little bit more easily. Graphs are often a little bit better for estimation. T-charts can be kind of cumbersome to fill out, but can be really quick and dirty if you want to answer a quick question about a number of hours worked and dollars saved. So they all have their advantages. And now let's move on to problem 2. Okay, here in problem 2, this is it's kind of a wordy problem, but it's not really that hard to break down. So let's just read through this. So Mrs. Jameson is a person at the school who's renting a bus for the 6th grade class to go on a field trip. So one bus company charges a flat fee of $100 plus $5 per student to go on a trip for this field trip. The other company charges $180 and no fee per student for a different bus. So this is company A. This is company A, and this is company B, or 1 and 2. Okay, so if the class is really small, obviously you want to go with company A. Let's say you have a 10-person class. So if you have a 10-person class, it's going to cost $100 plus 5 times 10 is 50. So that's going to be cheaper for company A than 180. But if the class gets really big, then company B is a better deal because after you get enough students, you're going to pass this $180 price. So let's model this using a graph, and let's see if we can figure out when each bus makes sense for Mrs. Jameson. So let's make ourselves a graph. We'll do it in light blue. And okay, so we need to let's see. So over here, we'll make on this axis, the x-axis, we'll have put number of students. And then we'll go from, say, 0 to, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. We'll see if we have to go further. And then here we're going to have the cost. So we'll go 0, 10, 20, 30, 40, 50. Yeah, I think we can do this. 10, 20, 30, 40, 50, 60, 70, 80, 60, 70, 80, 90. Now this isn't going to work out. So we got to go, let's do it like this. Let's go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, 1, 2, 3, 4. Yeah, I could have had this all drawn for you in advance. So this is going to be the cost in dollars. Almost always dollars will be on your y-axis. And this is your number of students over here. Okay, so let's look at company A, and let's draw that one in green. So this would be company A. And let's see, we have a $100 flat fee, so that could be our starting point, $100. 0 students cost 100. And let's see, $5 per student. So let's see, how many would 10 students cost? 10 students would cost 10 times 5 is 50. Let's see, 10 students, 10 times 5 plus 100. $100 flat fee plus our $50 for the students. So 10 students would cost 150. And now we can graph that. So let's go ahead and graph that. Whoops. Let's do it. There we go. Now what is so this, and we can write this. Let's go ahead and write this as an equation because we know how to do that. We know that our y-intercept is 100, and we know that our slope is what? What's our rate? We see this keyword per here, so there's our rate. 5x. So there's company A. This is our equation. This is our graph. And we're off, and we're, as I say, cooking with gas. Now let's go into a red, maybe a lighter red. We've never used this color, salmon maybe. And we'll do company B. So company B, we have our y-intercept. So we'll go y equals, well, what's our y-intercept? Our y-intercept is 180 because 0 students cost $180. But how many did 10 students cost? 10 students also cost $180. And 25 students even cost $180 because it's a flat fee. So our y-intercept is 180. And our slope, there's no per student cost. So there is no, it's like 0x plus 180, which reduces to y equals 180. So this is kind of one of our simpler lines, which is a horizontal line. Sometimes this confuses students. These horizontal lines and these vertical lines can be confusing, but they're actually simpler because they look just like this. If y is 180, then y is always 180. Doesn't matter what your x is. It's a flat line. And so now we have an interesting model. If we have, what can we say about these spots on our graph? What's interesting about each point on this graph? let's just take this down. Let's just see something kind of cool here. Let's look at if we had 4 students. Well, if we had 4 students and we went with company A, it would cost this much, $120 for 4 students on the green line, because that would be $5 times our 4 students plus 100. That makes our 120, which is represented right here on the graph. And how much does our company B charge us? Well, they charge us 180. Right? So company A is the better deal, and you can do that just by a straight calculation from your verbal model. 4 times 5 plus 100 is 120, and over here it's always 180. So company A is the better deal, but you can see it graphically too. So at 4, company A is better. I should probably switch this over to a different color. So let's do that right now. Let's go back to blue. At 4, company A is better. Let's see, how about at 10? We could look at the verbal model, but we can also look at the graph, and we can know that company A is better at 10 because it is lower, right? Company A is 150 with 10. Company B is still 180. So at 10, it's a better deal. At 10, company A is better. Now let's look up, on the other hand, maybe over here at 20. 20 is right here. Let's look at 20. Well, at 20, company A is $200 and company B is 180. So at 20, company B is the better deal. Are we getting this? So where is it that they are the same? Where do they cost the exact same amount? Well, at 180, let's look here at 180. Right here where they cross, they cost the same amount. And that's where at 16. So when the number of students is 16, let's see, at 16, company B at 16, let's look at this. Company B is going to be 180 because they're always 180. Let me write that nicer. And then company A is our 100 plus 5 times 16. So that's 180. So there's our break-even point. So if Mrs. Jameson is a good algebra teacher, she'll say, oh, well, it's 16 people, I can go with either. But if I have more than 16, I'm going to use company B. Let's see. At less than 16, use company A. At 16, it doesn't matter. And greater than 16, I'm going to use company B. All right. Let's lay down a happy cat. We deserve a happy cat for that one, I think. Now, let's move on, and we're going to do our last homework problem. And this is an interesting one. There's one like this on the homework, and this is hopefully pretty easy for you. The question is which line, and this is the last of our homework help, and then we're going to just say this is a wrap. So which line represents the cost of a phone? So now you have to pay for a phone, or your parents have to pay for a phone, and the plan costs you $60 a flat fee per month, plus $5 for every extra gigabyte. So it's a $60 per, so sorry, $60 flat for the month. And it's $5 per extra gigabyte. So if it's 0, so the idea, if it's 0, if you use 0 gigabytes, so if you just, your starting cost, your 0 gigabytes, this is, this is kind of like your starting cost. I want you to think about what is the equation of the line. So I want you to pause and write the equation of the line. And then I want you to guess or figure out which equation, A, B, or C, is the equation of a line that charges $5 for every extra gigabyte and $60 flat fee. Okay. Now I assume you're back, and hopefully you could figure this one out. And you could have done this by T-chart, by graphing, or the equation. But the equation of this line, this is our starting point, $60. So this is our y-intercept. And our slope is positive. This is our slope, which is a positive 5. So our y-intercept is 60. So if our y-intercept is 60, this A is out. And if our slope is a positive number, it can't be C, because it can't be C. This is a negative slope. So this is ruled out. And A is ruled out by it's got the wrong y-intercept. So it has to be B. It's got to be B. So let's just make sure we can write our equation here. So we should get y equals 5x plus 60. That is our equation. And so let's just make sure we have another point that looks like it works. So let's figure out what would happen if we had 10, or no, let's try 5. So if we tried 5 gigabytes, we should get y equals 5 times 5 plus 60, which is equal to 85. 60 plus 25 is 85. So we should have a point 5 comma 85. So if we went from 5, yeah, this is about 85. So I just reconfirmed that our answer has to be B. Happy cat. And let's get out of here. So hopefully this is useful. We're just getting started. Unit 5, we're going to be applying some of the concepts that we've learned in linear equations. We're going to be learning more in lesson 5, in unit 5, about equations and functions and increasing functions, and not just linear functions, but how to read graphs and communicate the information in graphs. It's a very powerful lesson. Hopefully a little bit more conceptual, a little more high level, and a little less hardcore math, which is good for some of you, and some of you enjoy that a little bit more. So it's not too long. So I think it's 14 lessons, and we'll be back with lesson 2 tomorrow. And keep your eyes out and loving it. We're gaining traction. More people are watching for longer hours. I got a few more subscribers this week. It's great. It's really fun to be teaching you guys, and I hopefully as we get we're past halfway in the year and getting towards the end. Hopefully it's all working out for you. So I'll keep it up, and you keep it up too.